The next topic we want to move on to is how we can use scatter plots, correlation coefficients, and linear models to start answering practical questions about applied problems. As a quick review, whenever we calculate that linear correlation coefficient R, that value will always be between -1 and 1, where a value close to 1 reflects a strong positive association, a value close to -1 reflects a strong negative association, and a value close to 0, which is right in between -1 and 1, reflects no association or a very weak association at best. What we want to do is look at visually assessing linear models and determine if they're a good fit, and then eventually what we're going to look at is whether those models can be used to make effective predictions about future or unknown values. We'll look at how we can do that. So the graph that we have first on the left, we can see it is a good fit for the data because the dots follow close to that straight line pattern, or that straight line pattern follows close to the path mapped out by those dots. So since the correlation coefficient R is likely close to +1, since we see an increasing pattern, we would say that this model can be used to make effective predictions about future or unknown values. There really is more that would go into that process of validating this statement, but we're going to look at this sort of simple approach for now. For the purposes of our class, if we see a good fit for the data, then our linear model can be used to make effective predictions about future or unknown values. Our second graph, we can see the linear model is still a good fit for the data. We see a decreasing pattern, which means that our value for the correlation coefficient is likely close to -1. That means the model can be used to make effective predictions about future or unknown values. But in the case of this third graph, we see again a case where the dots are not following any real clear pattern. That linear model has a slope that's close to 0. It's very close to a horizontal line. So this linear model is a poor fit for the data. And since that value for our linear correlation coefficient is likely very close to 0, that means this model cannot be used to make predictions about future or unknown values. So what we're looking for is a clear increasing or decreasing pattern, a value for R that's close to +1 or close to -1, to know that the linear model that we create can be used to answer some of these applied questions. If we have a correlation coefficient close to 0, or if that linear model creates a nearly horizontal line, we have a poor fit for our data. Using the model to make any predictions, to carry out any applied questions is really not very useful to us.